So for this lesson, we're going to try to set up word problems involving systems of equations. So for us, what does that mean? Well, that means we're dealing with systems of equations, so you should expect two equations, because those are the systems we've been dealing with, and two unknowns, or variables, an x and a y, or whatever letters you want to give your variables. Let's just jump straight into the examples. During the day at a movie theater, 32 people showed up to the afternoon show. If they charged $5 for students and $9 for adults and made $180 in admission fees, how many adults and students were at the show? Okay, there's a lot going on here, so let's orient ourselves with what is actually being asked. We're asked how many adults and students were at the show. Adults and students. So you want to find out how many adults there were, how many students there were. That should give you a sense of what variables to use. So I can say let A equal the number of adults, and then let S equal the number of students, right? And then what am I asked for? The number of adults plus the number of students equals something. And let me look for that in the question. It says during the day at the movie theater, 32 people showed up. Okay, so the number of adults plus the number of students must be equal to 32. That's your first equation. So let's look at the question again to see if we can figure out information that can guide us into equation 2. So in addition to saying there's 32 people at the show, we're also told that students were charged $5, adults were charged $9, and the total amount of money collected was $180. So $180 would be what you call the revenue, the amount of money you collected. And revenue is always going to equal the price of whatever product you're selling, like tickets, times the number of things you sold, in this case, the number of tickets that were sold. Applying that to what we'll call equation 2 here is we're told that adults were charged $9. So in that case, the price for adults was $9. And then you have to multiply that by the number of adults that showed up. But then you also have student tickets, and students were charged $5. And then you would multiply that by the number of students who bought the tickets. Well, we have variables for those two things, right? Number of adults is the letter A, number of students is the letter S. So for revenue, we would have, I'll just write a 9. So $9 times A adults plus $5 times S students equals a total revenue of $180. And at this point, look what you have. You have two equations with two variables. Fine, they're not an x or a y. If you're more comfortable with that, you can put x or y. But you have two equations, two variables. You should be able to solve this using either elimination or substitution. So for the rest of this lesson, what we're going to work on is just setting up that linear system. So writing equation 1 and equation 2. You guys should already be good with solving it. Just for this example, I'll solve it. So I'm going to use elimination, and I'm going to multiply equation 1 by a -5. So -5 times A, -5 times S, and 32 times -5 equals a -160. Why do I do that? Because then when I add these two equations, I'll have 4A, the S's get eliminated, equals 20. Therefore, A equals 20 divided by 4, which is 5. So there were 5 adults. Take that A number, and then I'll plug it into equation 2. 9 times A, so 9 times 5, plus 5S equals 180. Now I solve for S. 9 times 5 is 45. I'll subtract that from both sides. I'll get 5s equals 180 minus 45, which is 135. Therefore, 135 divided by 5 would equal 27. So what this is telling me is that there are 27 students and 5 adults. And of course, you can test out the equations by plugging those numbers back in the original equations and making sure they hold true. Okay, so that's how to solve the equation. For the rest of the examples, we're just going to set up the two equations. Next example. Frank has $3.85 in dimes and in quarters, and there are 25 coins in total. How many of each type of coin does Frank have? This is actually a similar question to the first example, so if you think you can solve it yourself, go for it and check your answer with mine. I'll move ahead and start with a couple of equations. Here's a key point. There's 25 coins in all, and some are dimes and some are quarters. So let D be the number of dimes, Q be the number of quarters. So my first equation can be the number of dimes plus the number of quarters equals those 25 coins. The second equation can deal with how much all of this is worth. We're told that all those coins together give you a total of $3.85. Well, how much is a dime worth? Remember, a dime is $0.10 and a quarter is $0.25. So if we take the number of dimes and multiply that by how much it's worth, 0.10 multiplied by the number of dimes, and do the same for quarters, 0.25, multiply that by the number of quarters. So this is how much all the dimes are worth. This 0.25 times Q is how much all the quarters are worth. And then the 385 is how much all the coins together are worth. How much all the coins together are worth. And that could be my second equation. So I have two equations, number 1 and number 2, two unknowns, D and Q, and I can use either substitution or elimination to get a solution. I'll leave that for you to do. Next equation, we have Lisa's sandwich shop. We have 2 chicken sandwiches, 4 tuna sandwiches, and all that together costs $18. 5 chicken sandwiches and 6 tuna sandwiches cost $34. Find the cost of each sandwich. Well, we have chicken and we have tuna. Let C be the cost of the chicken sandwich, and let T equal the cost of the tuna sandwich. Well, when we bought 2 chickens and 4 tunas, our total cost was $18. We can have that as our equation number 1. So 2 chicken, 4 tuna cost $18. For equation 2, we have 5 chicken and 6 tuna cost $34. 5 times the cost of the chicken sandwiches plus 6 times the cost of a tuna sandwich equals a total cost of $34. 2 equations, 2 unknowns. You can solve this by substitution or elimination. Okay, this one has nothing to do with sandwiches or tickets or anything like that. It's just about numbers. We're told that 3 times the larger of 2 numbers is equal to 4 times the smaller. The sum of the 2 numbers is 21. Find the number. So you can use X for one number, Y for another number. Since there's a larger number and a smaller number, I'm going to say L is the larger number, and I'm going to call S the smaller number. Again, you can use whatever letters you want, but it's good to define your variables. Use letters that you think will help you keep track of what's what. So L for larger, S for smaller makes sense to me. And now let's just break down the sentences and see if we can't build equations off of those. 3 times the larger number, 3 times the larger. So that's, for equation 1, I can start with just saying that's 3 times L, the larger number, is equal to 4 times the smaller number. 4 times the smaller number. There you go. Underlined in blue, that is equation number 1. 3 times the larger number equals 4 times the smaller number. Okay. And how about equation 2? The sum, that's adding. The sum of those two numbers, so if I take the larger number and I sum it or add it to the smaller number, it equals, or it is, 21. Equals 21. Again, in this case, you have 2 equations, 2 unknowns. You should be able to solve this using substitution or elimination. For me, my strategy would be to use elimination. I could just say L equals 21 minus S, and then plug that into equation number 1 to solve for S, and go on and on with the substitution technique. But I think substitution is probably appropriate for this equation, for this linear system, that is. But again, I'll leave that for you to do while we move on to the next example. Okay, here you have a perimeter of a rectangle, and they talk about the width and the length, and they want you to find the dimensions, so that's width and length of the rectangle. When it comes to something like this, it might be a good idea to draw an example. So there's a rectangle. And this word perimeter, remember perimeter means the outside. So I just drew it in blue. The perimeter of the rectangle is this whole outside area of the rectangle. That equals 22 centimeters. We're also told that the width is 3 centimeters less than the length. So that means the width is smaller. Width is smaller than the length. So in my diagram, the width is the smaller side. So I'll call that the width, and that would be the length on the bottom. So we know one thing for equation 1, or we can write equation 1 already, because we know that the width of the rectangle is 3 centimeters less than the length. So let's think about this. Does that mean the width minus the length equals 3 centimeters? Or does that mean the length minus the width equals 3 centimeters? It can be confusing to write, to translate words to an equation, but we can always test it out in our head. Now, is the width the smaller, or is width the larger number? If the width of the rectangle is 3 centimeters less than the length, width is smaller. Okay, now let's make up some numbers. If the width was a smaller number like 5, and the length was a bigger number like 8, 5 minus 8 is actually a negative 3. So writing that first way, W minus L, can't be correct, right? It can't be correct. But now you said length is 8 and width is 5. So width is the smaller number, like we already logically came to the conclusion that width is a smaller number. 8 minus 5 does equal 3. That is correct. So writing this equation 1 as L minus W equals 3 is the correct way, whereas W minus L equals 3, that would be incorrect. How about equation 2? Well, for equation 2, we're told the perimeter, or the outside length of a rectangle, outside length of the rectangle is 22. But what's a formula for perimeter? Well, perimeter is the width plus the length plus the width again plus the length, or 2W's plus 2L's equals the perimeter. So 2W's, 2 widths, plus 2 of the lengths, 2L, equals the perimeter, which we're told is 22. Okay, we have two equations, two unknowns, W and L. You should be able to solve this using substitution or elimination. Last example, and another one where it'll be a good idea to draw a diagram. There's 30 identical rectangular tables placed end to end. Their perimeter is 306 feet. When the same tables are placed side by side, their perimeter is 190 feet. Okay, so what it's saying, and for A, this will help us, it says draw a diagram of the first 3 tables to illustrate each arrangement. So we'll say end to end. The end-to-end arrangement would be like this. You have rectangular tables and they're placed end to end, so this way. And that's just table 1, 2, and 3. We know that that's going to go on for until you reach the 30th table. You might as well draw that 30th table over here. When those same tables are placed side by side, their perimeter is 190 feet. So what does side by side look like? Side by side would look like this. So that's table 1, 2, 3, and that'll go on and on and on till you reach table number 30. Now, let's label the length and the width on these tables. Here's the width, and here's the length, right? And for the end-to-end, that's going to describe my equation number 1. Okay, so if I look at equation number 1, look how many widths are going to be in my perimeter. There's going to be the width on one end, and then all the way on the other end, the width at the end of the 30th table. So my perimeter is going to be 2 widths plus how many lengths? Well, there's going to be lengths added up for each table, and you can do that twice on the top and the bottom, right? So there's 30 tables, so you're adding up 30 lengths times 2. So 2 times 30 table lengths. To clean this up a bit, we can say 2W plus 60 length. That equals the perimeter of 306 feet. That's going to be my equation number 1. Let's analyze equation number 2, or the side-by-side section. Here you have a width for each table on the top and the bottom. So for equation 2, now you have a similar kind of thing. 2 times 30 tables of widths plus, now you have the length on one end plus the length all the way on the other end, 2 times the lengths, and we can simplify that by saying 2 times 30, or 60 widths, plus 2 lengths, that equals 190 feet for the perimeter. For solving that, I'll leave that with you. My preferred method in this case would be elimination, and what I'd probably do is multiply that first equation by a negative 30 to cancel out the W's, or eliminate the W's as my first move. What you should end up with, if you're curious, would be the length should equal 5 and the width should end up equaling 3 as your solution. Alright, that's it for this lesson. I'll post up the homework and get that done and check your solutions. Thanks.